We have finally made it. Today we're working the very last lesson on our module that has been focused heavily on the Pythagorean theorem. And today we're going to be combining the Pythagorean theorem with the distance formula to find out who's going to get to the taco cart the fastest. We're going to start off by watching a video.
So I'm there on the beach with my friend Ben when we notice a taco cart up the road. Ben wants to walk straight over, but I'm thinking we walk a lot slower in the sand than we do on the street. So I say we walk straight to the street and then down the street to the cart. So we went our separate ways.
So, the first question we have here is which one of them do you think is going to take and reach the taco cart first? And let me figure out, I'm not on the right screen here. Let's see if I can get back to the screen we want to be on. So do you think that Ben is going to make it to the taco cart first? Or do you think the other one is going to make it too? Let's see, who are our two people we forgot? I don't even remember the name. So do you think that, let's jump over to this page. I bet it'll tell us right here. Who do you think will make it to taco cart first? Yeah, don't really. Dan and Ben. There's our names. Is Dan going to make it first or is Ben going to make it first? If you're in class, we're going to let you vote one way or another on it. But the question is, what do we actually need to know in order to solve this problem? Well, we're going to need to take and come up with some things that we need to know. We're going to need to know, for starters, let's get our text box going here. We're going to need to know how long each leg is and how long, the hypotenuse is. What else are we going to need to know? We're also going to need to know how fast do you walk on sand and on the road? Because if you walked on the beach down here, you know it's hard walking on sand. It's a lot easier to walk on a solid surface. So that's going to be the first two questions, are things that we're going to need to know. Now we're going to take and jump back over to our video, our PowerPoint here, and the question was Dan or Ben, who's going to make it to the taco cart first, and we're going to discuss with your elbow partner what information is needed. We've already talked about that as well. And now they've given us some distances. They've given us this distance from their starting down here. So one of them is going to walk to the road and then use the road to walk to the cart. And we need to figure out how long the route is for the other one to walk right straight to the cart. So if we jump back over to our instructions, it says label Ben's route with a blue pencil and Dan's route with a red pencil. Now I had to go back and watch the video again. It said Ben wants to walk straight over, so I'm going to take on my first page here. Ben's a blue, so we're going to take and use my line tool right here. Oh, that's not the one I wanted. Right there, and we're going to change the color to blue. So Ben is going to be this distance right here. Meanwhile, Dan, they wanted us to do in red, so Dan is going to go all the way up, get on the road, and then go all the way over, just like that. Jump back to our next questions. We have done that part. We labeled Ben is blue and Dan is red. Next, we're going to calculate the Ben's total distance traveled and show your work that leads to the answer. So we're going to need to get some information here. Ben was blue, so we need to figure out what the hypotenuse is, and to do that I'm going to jump back over to this screen, which gives us some numbers. So we've got two legs and Ben is going to be the hypotenuse. So we're going to need to come back over and do some actual math. So we're going to write down our formula first. A squared plus b squared is equal to c squared, where I got 325.6 feet all squared, plus 562.6 0.6 feet all squared is going to equal to c squared. And of course, we know that c is bend, the hypotenuse. We're going to take and grab our calculator. When we're going to take with that 325.6 times 325.6 is going to equal to, woo, look at that big old number. I'm going to drag that off to the side where I can actually watch it. Try to drag it off the side. Where did it go? That is weird. Here we go. So we're going to take from there, and that's going to be 106,000, 15.36 feet squared. And then we're going to take and do the other fellow, which is going to be the other leg, 562.6 times 562.6 again. That one's going to give us 316,518 and 7600 feet squared. All, of course, is equal to c squared. Now, I'm out of room, so I'm going to draw a line here, and then I'm going to take and combine those two numbers, which is going to give us 422,534 and 1200 feet squared is equal to c squared. And then from there, we're going to take the square root of both sides, the square root on the left and the square root of right. The square root of c squared is, of course, going to be c. And then over here, if I take the square root of that number, it's going to be, we're going to call that a nice, beautiful 650 feet. So we're going to say that this distance here is going to equal to 650 feet. Remember, the square root of feet squared is feet. So that is going to be the distance that Ben traveled. And we can come back up here, and we're going to write this in right here, 650 feet right there to represent how far Ben traveled. Now, calculate Dan's total distance. Well, I already wrote down his distances earlier, so that's going to be 325.6 feet squared plus 562.6 feet squared. And when we add those together, we're going to, of course, the feet squared is coming down. That's going to give me a 12. Carry the 1. That's going to be 6, 7, 8. And that's going to give me another 8. And that's going to give me another 8. So his total distance is going to be 888 and 2/10 feet. Actually, not feet squared. That's just going to be feet. I need to get those squareds out of there, and out of there, and out of there too. It's just feet, no longer feet squared. Good. So now we know how far they travel. Each one's traveled. And the last question is, who traveled further? Show the work that leads to the answer. Well, we've already shown the work up above right here, and that is going to be Dan traveled further. And as far as showing the work, it's up there. I wonder if they're wanting us to find out how much further. So jumping over and looking at the answer key, it does actually show that they did want to find out how much further. They didn't ask that question, but they did want to know. So how much further did Dan travel? He traveled 238 and 2/10 feet farther than Ben traveled. Now, the next question is, who's going to make it to the taco cart first? And they have to show the work that leads to the answer. This is where some really cool stuff is fixing to take place. So to do this problem, I took and created two columns here, one for Ben and one for Dan. And we need to remember we have something called the distance formula, which you should already know. Your distance formula says distance is equal to rate times time. D is your distance, R is your rate, also known as your speed, and T is going to be your time. And then from there, I know that the distance of Ben was 650 feet. But do I know what the rate of Ben is? Actually, I do. Because, we got a problem here, though. Ooh, this can be tough. So let's jump back over to our PowerPoint slides, and we're going to scroll up here, and we're going to see the next slide that when they're walking on the road, they travel 5 feet per second, but when they're walking on the sand, they travel 2 feet per second. That's going to complicate things for the one that took the long road. And just verifying it, Ben took the direct route, so Ben is going to end up being easy. So we're going to take, and for this one, the rate is going to be equal to 2 feet per second times some amount of time. So if we were to take, and divide both of these by, let me show you how to do proper addition of 2 feet per second times time. I'm going to multiply both sides by the reciprocal of this. That's going to give me 650 feet over 1 times 1 second over 2 feet equals 2 feet over 1 second times 1 second over 2 feet times time. And in doing that, some cool stuff is about to happen. These seconds just divided out here, and these 2 feet divided out here. But right here, feet and feet also divided out, and we can simplify. 2 goes into 2 once, and 2 goes into 650 325 times. So our answer, 325 times second, means it's going to take 325 seconds is going to equal to, let me put my units in there, the time it's going to take Ben to get to his destination. Now, Dan's going to be more complicated. So we're going to start off by writing that distance formula again. And this time, I'm going to take and solve for time itself. So I'm going to divide both sides by the rate. And in doing that, these rates divide out. And that gives me time is equal to distance divided by the rate. Now that's important because Dan has 2 different rates that he travels. He has the rate that he travels on the sand plus the rate that he travels on the asphalt. So for what we have for Dan, we're going to end up taking his first distance. Let's jump back over to, actually it should be up at the top of this page. If I can get it to scroll up, his first distance was 325.6 feet. So that's going to be 325.6 feet divided by, and his rate there was going to be 2 feet per second. So we're actually going to multiply a second on top. It's going to be pretty cool how this is going to work out. Just watch. Plus, and the second distance was going to be 562.6 feet, 562.6 feet. And once again, he's going to be dividing this one by, but if you take a look here on the asphalt, it's 5 feet per second. So we're going to have 5 feet, and then on the top, per second. This goes opposite of where it was. Now, what's going to divide out? Well, my feet here just divided out, and my feet here just divided out. And then from there, we're going to take and let's grab up a calculator and make this math super easy. If I can find my calculator, let's do it this way. There it is on that screen. So we're going to take, and on our calculator, we're going to do 325.6 divided by 2. And that means that this distance is going to be 162. Was that 0.6? Nope, 0.8. And the only unit left here is going to be seconds. And then when I take this one, 526.6, and divide it by the 5, that's going to give me 105.32 seconds. And we add those two together, come back over here, plus 162.8 is going to equal to the total time for Ben to travel is going to be 268.12 seconds. So in the end, who was the actual faster person? The faster person, I'm sorry, not Ben, Dan. The faster person is going to be Dan, who traveled the distance in 268 seconds by going the farther distance up and then over. Meanwhile, Ben trudged through that sand all 650 feet of it, and it took him 325 seconds to do it. Now from here we've got the final part where we're going to take and do one of the 2 extensions below. Option 1 says, let's say that we change the speed that they walk on the boardwalk. That's a boardwalk? Look like asphalt to me. All right, anyhow. And what speed must it be for Dan and Ben to arrive at the same time? And then the option 3 say, let's say a third friend, Anne, arrives and she starts at the same place choose a route for n that you think would be faster than the routes that Dan and Ben use. These are two options which we're not going to waste time doing right now, and I honestly don't know if we're going to do them in class. But we do have a home assignment that you need to be ready to knock out to turn in to me. And that is going to be this exit ticket, where you're going to work this problem. It's going to require you to use that distance formula that we talked about, and we're going to be focusing on speeds and times and things of that nature. You got lots of space underneath to give me good supporting work. Make sure you're including formulas in everything you do. I look forward to answering your questions in class tomorrow, and there's probably going to be some. I'll see you tomorrow.